Let's go ahead and look at the solutions to the question behind me, where we evaluate the 6 trigonometric functions at theta, where theta is given to us in each case by a right triangle. For these problems, we'll need to recall the definition of our trig functions on the right triangle. For example, the sine of theta is the opposite side over the hypotenuse. So we also need to recall how to find the opposite, adjacent, and the hypotenuse of a right triangle. Start that again. Holy fucking shit, man. Why is this so hard? It's getting tired. It's getting late. I think you gotta fucking go to bed in just a minute. Alright. Let's look at the solution to the question behind me, where we evaluate the 6 trigonometric functions at theta, where theta is given to us by a right triangle in each case. For these problems, we'll need to recall the definitions of the trigonometric functions on the right triangle, and also recall our techniques for finding the opposite side, the adjacent side of the hypotenuse of a right triangle. So we'll do all those first in part A together. So note that given some angle theta, an acute included angle of a right triangle, we can find the adjacent side to be the side touching that angle theta, or on either the initial or terminal side of theta. The longest side is always our hypotenuse. The opposite side is the side not touching our angle theta, or the side opposite the angle theta. So we'll start with our evaluation of sine theta. We'll recall the sine of theta is the opposite side over the hypotenuse, or 4/5. We could recall then that the the cosecant of theta is defined as the hypotenuse over the opposite, 5/4, or equivalently is the reciprocal of sine of theta, so we could have found that in either way. We'll be able to find cosine theta. It's the adjacent side over the hypotenuse, that's 3/5. By the reciprocal definition of secant theta, or by its definition on the right triangle, we can find that's equal to 5/3. The tangent of theta we see is 4/3. The cotangent of theta is 3/4. And we find our solutions. Let's go ahead and look at part B now. So for part B, we might first start by identifying our adjacent side, our opposite side, and our hypotenuse. Let's find the sine of theta first. Opposite over the hypotenuse, 1/√2. If we rationalize that denominator, we'd have √2/2. We could evaluate the cosecant of theta. That's just going to be √2. The cosine of theta is defined as the adjacent side over the hypotenuse, or 1/√2, or √2/2. By the reciprocal definition, or definition on the right triangle, we'd be able to find that secant is √2. Tangent of theta is our opposite side over our adjacent, 1/1, or 1. So the cotangent of theta is also 1. So note that these evaluations for sine and cosine are not unfamiliar to us, or they should be familiar at least. We know that the sine of theta equals √2/2, at least at the angle pi force, or at 45 degrees, and the cosine of theta is equal to √2/2, also at 45 degrees, or pi force. This actually corresponds to one of our special right triangles. That special right triangle is the 45-45-90 triangle. So we'll find that the right triangle with acute angles 45 degrees and 45 degrees, again sometimes called the 45-45-90 special right triangle, will always have the ratios 1 for its legs and the square root of 2 for its hypotenuse. So every right triangle with the angle 45-45-90 is similar to this right triangle with legs of length 1 and hypotenuse of √2. Finally, let's look at part C. So part C here, we'd start by identifying our opposite side, our adjacent side, and our hypotenuse, and just run through our definitions for sine, cosine, tangent, and their reciprocal functions. See that we can find sine theta is our opposite over our hypotenuse, which is 1/2. See that we could find from there cosecant of theta is 2. The cosine of theta is our adjacent side over our hypotenuse, √3/2. So our secant is the reciprocal of that, or 2/√3. The tangent of theta is defined as our opposite side over our adjacent side, say 1 over root 3, and we can see our cotangent of theta is the reciprocal of tangent, or just root 3. Note again that these evaluations of sine and cosine at theta, or sine, cosine, and tangent at theta shouldn't be unfamiliar to us. We should recall these evaluations are true for the theta value. Theta equals 30 degrees. And it turns out that this corresponds, this triangle we're working with here, to another special right triangle, to the 30, 60, 90 special right triangle. And that special right triangle, if given a right triangle with included angles of 60 degrees and 30 degrees, we know that this right triangle will always have the dimensions, or be similar to a triangle with dimensions 1, the side opposite 30 degrees, root 3, the leg opposite 60 degrees, and 2 as our hypotenuse.